So let's talk about data warehouse schemas next. Now, if you've done any sort of database work, you're familiar with the concept of a schema, but there are some specific concepts to data warehouses we want to talk about. If previously you've only dealt with source systems and source data, you just hit the tables that are given to you as a data analyst. But within a data warehouse, these might be structured in specific ways that we want to talk about. Now, a couple of shared components to any data warehouse schema are things called fact tables and dimension tables. Let's start by talking about a fact table. Let's go back to the example of an online course website like mine, Sled Education, and let's imagine that I have a fact table surrounding each enrollment on my website. So whenever a student enrolls in a course, I might have a fact table in a data warehouse associated with my website that contains all the facts associated with that enrollment. Typically, a fact table will contain all of your main keys associated with your queries. So my enrollment might be described by the identifier of the course that a student enrolled in, by the identifier of the student, and maybe an identifier for the payment associated with that transaction that they used to actually pay for that enrollment. And I'll probably have a timestamp on there as well of when that enrollment happened. So that's an example of a fact table. Now, each one of those keys within the fact table can be split out into a dimension table. So that course ID, for example, represents a course dimension table. We'll call it dim course here in this example, and that would contain all of the data associated with that course. So I have a dimension of course information associated with that fact table that's tied together using the course ID, and within that dimension table, I might store the name, description, the instructor associated with that course, and the price of that course in that dimension table. I might also have a dim student table. That's a dimension table for the student, in this case tied together by the student ID, and that might contain information about the student such as their name, address, email, and maybe their preferred payment method or something like that. And finally, I can split out my payment ID into a payment dimension table. That's tied together by the payment ID key and might include things like the payment type. What kind of credit card was it? Was it PayPal, something else? The amount of the payment, any tax payments associated with it, the authorization code that came back from the payment processor, stuff like that. So these are examples of dimension tables. So let's see how they fit together. So moving on to this next diagram, let's look at what's called a star schema. This ties it all together. So we might have a fact table that contains keys that link it together to the various dimension tables that we have. We call this a star schema because we just have these individual dimension tables branching off from that fact table. Kind of looks like a star if I had, enough points coming off of it, right? So in this case, we just have a very basic relational database design in our data warehouse where we're tying all of the keys within the fact table to dimension tables that contain information about each one of those key types. This is what we call a star schema. Very simple. Going on to our next diagram here, we can see how we can split that out even further. So perhaps my dimension tables contain links to other dimension tables. For example, in this case, our dimension course table contains an instructor ID instead of just an instructor name. Maybe that in turn links to another dimension table. In this case, we're calling it dim instructor. That might include information about the instructor, including their name, biography, the PayPal account associated with them so I can pay that instructor, and that instructor's email address, among other things. That's tied together through this new instructor ID key. So since we have this additional layer of dimensions here, we're now going to call this a snowflake schema. It's called a snowflake schema because if you were to split this out even further, you could in theory have multiple dimensions associated with each dimension, right? So this starts to branch out very much like a snowflake. So visually, it just looks more like a snowflake than a star. That's all there is to it. Taking this even further, you can see that we've split out the saved preferred card for payment for each student into a saved card ID key, and that might link off to another dimension table called dim saved card, where we have information about that saved card, including what kind of card it is, the account number, the CCV code, the expiration date, stuff we need to store to actually process a payment using that card. Naturally, you'd want to make sure you had really tight security around that particular dimension table. And just to round out the example, on the payment dimension table, we've introduced a tax payment ID key that branches off into a dim tax payment dimension. And this just contains information about the taxes associated with that sale, such as what type of tax it is, the percentage that was used to compute that tax payment, who that tax is payable to, and whether or not it's been reported to the appropriate taxing authorities. So again, to recap, Within a data warehouse schema, we have fact tables that contain all of the main keys associated with whatever you're trying to query. In our example here, it's an enrollment composed of a course ID, student ID, and payment ID, and maybe some other data as well. If we just have one layer of dimensions associated with that fact table, we call that a star schema. So if I'm just looking at the course, student, and payment dimensions there, just branching off one level from the fact table, that's called a star schema. And if I take this further by having dimensions upon dimensions, we call that a snowflake schema, where I have multiple layers of relationships within my dimension tables, okay? So those are the main concepts of data warehouse schemas: fact tables, dimension tables, star schemas, and snowflake schemas.